Okay, now again for Anna, the light just travels up and down in her reference frame, and so the round trip travel time is just 2 times the length of travel divided by the speed of light. And again, we did this little algebraic manipulation for a reason which will become clear in just a second. But for Bob, Bob actually sees the cart move to the right as the light pulse travels up, okay? And so he sees a path of the light that looks like that. Now, when it reaches the event, which corresponds to the light pulse reaching the mirror, is observed by another person in Bob's rest frame, in the Earth frame. We'll just call it Bob's twin, Bob 2. And so that's so Bob doesn't have to run over here or anything like that. It's just another person that's looking. Okay. So for Bob, what we have to think about is that he sees the train car move a distance v times delta t in his reference frame to the right when the light pulse moves up a distance L. Okay. And so the hypotenuse of this triangle, which is the total length of travel for the light, according to Bob, is just by Pythagorean theorem, is just the sum of the squares of the two arms. Okay. So then if we use this, we can say that 2 delta t, remember delta t now is not prime, so this is in Bob's rest frame, is equal to this distance of the light travel according to Bob, okay, divided by the speed of light. Remember, number 1 here, c is the same for all inertial frames, so he sees the same speed, and then we multiply by 2 because if we want to also calculate the time that it takes to come back down, which would just be symmetric. Okay, so now if we again, if we manipulate this a little bit, we can get this expression. We just square it, bring the c over, 2's cancel. Okay, now we're going to, now you see why now you see why we squared this expression over here, because now we can plug in the expression for L square in terms of delta t prime square, which is what we want to do. Remember, we want to relate delta t and delta t prime. Okay, so this now becomes again after that substitution. Okay, so now let's just do the algebra. Okay, and you can follow along with this at home. Okay, so finally and I'm going to make one more manipulation here so that we get delta t squared. Don't worry, this is a little bit messy down here at the bottom, but we'll fix it up later, is equal to delta t prime squared. Oh, actually, okay, here I've basically done the algebra for you. Delta t squared equals delta t prime squared times the ratio 1 over 1 minus v squared over c squared. If you then take the square root of that and set this quantity equal to gamma and beta equal to v over c, then you get what I wrote down. So the delta t is equal to gamma times delta t prime.